Okay, so for number one, we kind of went over it in the previous video, but ABE is going to be congruent to EBC. So ABE is 43 degrees, right? Because BE is the angle bisector of ABC. Okay, so we're over here in question number two, and we know that these two distances are congruent, right? AY and AF, and we know they form the same angle, a right angle, with the sides of the angle. YBF. So we know that AB, because of the converse angle bisector theorem, is an angle bisector. So YBA is equal to 47 as well. Okay. We go to question number three. We have the same setup, right? We're given that these distances are forming a right angle with the sides of the angle, and we're also given that angle MVK is congruent with KVT because of those little arcs in there, right? So we know for certain that VK is an angle bisector of angle MVT. And because of the angle bisector theorem, this one right here, we know that these distances are congruent, right? So we could set 2x plus 1 equal to 3x minus 8. You're going to solve for x, so we'll get x is equal to 9, but they're looking for mk. So we need to take the 9 and plug it in right there for x. So it's going to be 2 times 9 plus 1, so it's going to be 19. Right? X is segment mk is equal to 19. So here we're given that the distances from the line here are congruent to the sides of the angle. So that means that our converse of angle bisector theorem is going to kick in. And we could say that this WL is an angle bisector. And we could set this expression or this angle equal to that angle, solve for x, right? We should find that x is equal to 4, but they're looking for angle EWL. EWL, so we're going to take the 4, plug it into the x here. That's 28 plus 5 is 33. So this angle here would be 33. All right, lastly, we have these in-center problems, okay? So here we have in-center and the in-center theorem. So what is an in-center is the question. And so what it is it is the line that is created by the angle bisectors of a triangle. So this line here, let's call it the angle bisector. So that means these two angles are congruent, right? And then we're going to draw another angle bisector coming off of this vertex over here, like so. And that means that this angle is congruent to that angle. And then we're going to draw our third angle bisector. Is going to be coming off like this. And so this angle here, is, oh shoot. Oh goodness, what am I doing? Is congruent to this angle over here. Okay. Now, if we have our three angle bisectors, they all meet at what we call the in-center, right? The in-center. And the in-center has a unique property that it is equidistant from the sides of the triangle. So the in-center is equidistant to the sides of the triangle. Now, what does that mean? That means if we go ahead and draw, is there a way to erase here? Maybe not. So if we go ahead and draw a line from the in-center to the side of the triangle, that forms a 90-degree angle. Over here, we draw that line that forms a 90-degree angle, and over here we draw that line that forms a 90-degree angle. Then all of these are congruent distances because the in-center is equidistant to the sides of the triangle. Right? But remember that these lines have to form the same angle, and typically we use a right angle. Right? So if we have this set up like this, then we could say that this line segment is congruent to this line segment, congruent to that line segment, because that's the property of an in-center. So we're coming back to our problem over here, and we're trying to find each measure. So MU, right? MU is here. U is our in-center. We're given that. And so since U is our in-center, it is equidistant to the sides of the triangle. You can see we have our 90 degrees on these lines, right? MU, PU and BU. So that means MU is congruent to PU. MU is also 5, right? And so is BU is also 5. Okay, great. Now here we're looking at UGM. UGM. So this angle right here, what is it, right? Well, we know that the incenter is created by the intersection of the angle bisectors. So we know GU is an angle bisector, meaning it splits this angle into two congruent angles. So BGU is congruent to UGM. So UGM is 28 degrees. Okay, that's this one right here. Now we're looking for PHU. PHU. Again, this line here, HU, is a angle bisector. So that means this angle here, 8MHU, 21 degrees, is congruent to PHU, also 21 degrees. Lastly, we have HU. It's this line. How do we figure out what it is? Well, this triangle over here is a right triangle, right? Because we have a right angle here, we have a right angle over here. We have this side is 5, and this side is, this leg is 12. So we're looking for the hypotenuse. And you could do that or find that using the Pythagorean theorem, and you'll find that HU is 13. Okay. So anyhow, that's these problems here, and that's the lesson for today. Once you finish, we want to go ahead and move on to the IXL practice exercises.